morning. Happy Monday, everybody. I'm going to go ahead and run a couple notes for you. I'm going to do a derivative of the inverse mini lesson just in case it shows up on an FRQ. So let me see if I can pop over. Hopefully you're looking at, whoops, you're looking at this right now. See if we can unzoom it. I don't like that. Alright. Nope. Okay. Alright, so let's take a look at this and see how this comes out. So, functions that are inverses of each one. I cancel. Okay. I don't know what we're doing. Hopefully we're making a video that's going to work. Wouldn't be me if I wasn't like all goofy. Alright. So, long story short. Two functions that are inverses of each other, their derivatives are also related. Alright? So if you know that two functions are inverses, even if you don't know the explicit information about their functions, you know how their derivatives are going to be related. And the quickest way to show this is to show if we took a relationship that guarantees we're talking about two inverse functions. The composition of two inverse functions, f of g of x, would give you x. Okay, so knowing that means that f and g are in fact inverses. Now, if I take the derivative of this using chain rule, f prime of g of x times g prime of x would equal 1. That's me taking the derivative with respect to x. And so all I have to do then is do a little dividing. G prime of x is 1 over f prime of g of x. So the derivative of the inverse function, the derivative of the inverse of a function is 1 over the derivative of the original function, if we want to call one of them the original. So let's say we call f the original and g is now the inverse of that. If I want the derivative of the inverse of f, it'll be 1 over the derivative of f at g of x. Okay. So we can look at this a couple ways. This is probably the most confusing part, is that, well, what does this mean? You know, what number is that? What do you plug in? And so I'm going to try to show you on the next example. Okay. But the derivative of the inverse is 1 over the derivative of the original at a slightly different value. Okay. So if this is a particular x, this is the y that goes with that x from the inverse function. This is not a great topic to do on a video, and I honestly don't think you're going to see it on a test, but just in case you would, let's take a look at it. Algebraically, this wouldn't be a problem. You don't have to know any kind of shortcuts of algebraically. If you want to do an algebraic one, and this is saying find the derivative of the inverse, okay, then create the inverse. And create the derivative. Now, this is the inverse. Now I take the derivative, but I'm taking the derivative with respect to x. So this is going to be 1 over 3y squared equals the derivative that I'm looking for. Now, the problem is x equals 9. x equals 9 on the inverse function. So you've got to take the inverse function and figure out what the y is. And then that y goes here, and that's how I got y 12. Okay. So I've given you an x, you have to find the matching y from the inverse, and that's what goes into derivative. That is this. The derivative of the inverse at a particular x is 1 over the derivative of the original function, but at that particular y. Here's the original function. Okay, so another way to look at this is original function y equals x cubed plus 1. Original derivative 3x squared. So my inverse derivative is going to be 1 over 3y squared. But the thing is, what do you put in for y? That's always the trick. And it's not the y that comes from the original. You still have to think about an inverse. You have to think about on the inverse function when x equals y cubed plus 1, when x equals 9, that y would equal 2, and that's what goes in there. So the rule is pretty easy to remember. Okay, that 1 over is not too bad. You don't even have to remember that shortcut rule if you've got something algebraic, is you can write the inverse and then create the derivative, but the trick is what number do you put in here? Okay. So, if I were going to do this one, if I want my shortcut, this is, my derivative is 1/2 x minus 4 to the negative 1/2. So the inverse's derivative is going to be 1 over 1/2 y minus 4 to the negative 1/2. Now, I still have to think about x equals the square root of y minus 4 when x is 2. Y is going to equal 8. Okay, so on the inverse function, when x equals 2, y equals 8. So this is going to be a 2, a y minus 4 to the 1/2, when that's an 8, equals 2 times 4 to the 1/2. It turns out to be 4. I'm doing this quickly because I know you can stop it and you can go back. Let me go read back and do that. If I wanted to do this without remembering this shortcut, okay, x equals the root of my inverse is that x equals the root of y minus 4. So 1 equals 1/2 y minus 4 to the negative 1/2 times dy dx. Take the derivative implicitly. And so 2 over y minus 4 to the negative 1/2 is dy dx. So there's that derivative again. That's the derivative of the inverse. Oops, dx. It's just what do you put in for that. And you have to remember if x equals 4 in the inverse world, right? Is that what it was? X equals 4 in inverse world? Or was it x equals 2 in inverse world? X equals 2 in inverse world. I was like, wait a minute, that wasn't going to give me the right number. Okay, that's right. So if x equals 2 in inverse world, I'm in inverse world. And so y has to equal 8. Okay. So this becomes 2 times 4 equals 4. Okay. So I have a high probability. I feel like the probability is pretty high that if this is on the test, it is not going to be algebraic like this. It's going to be less specific. It's going to be more generic, like something like this, okay, where they've given you some information. And it's incomplete in that you don't have all the information, so you basically have to know the relationship or you can't get the derivative. Okay. Obviously won't be multiple choice, but they could tell you that given two things are inverses, okay, so we have the inverse relationship. We know information about one of them, and we know information about the derivative of the other. So we have, and we're asked for the derivative of g at 3. Okay. So if g is inverse world, okay, g at -3 is 2. That's the x, that's the y. Then the derivative of g at -3 would be 1 over the derivative of f at 2. Okay, you have to know the shortcut relationship. The derivative of g at a particular x is equal to the derivative of f at the related y, where that xy is the inverse function. Okay. G of -3 is 2, and so 1 over f prime of 2 equals 1 over -1/3, which is -3. Okay. I could see this. You could have a lot of information on a table. Find f and g are differentiable, f and g are inverses. Find the derivative of f at 4 if g of 4 is 3. All right, so in this case, f kind of is at the inverse that we're focusing on. I want f prime at 4. Now here's the part that's tricky. F of 4. I need to know what that y is. Well, f of 4 equals something means since g of something that equals 4. That means that magic y that we're talking about is -1. So if I want f prime at 4, I'm going to have to go 1 over g prime at -1. So 1 over 5. Okay. You can have this relationship in front of you on a piece of paper so that if you need it, it's available. You don't have to have it memorized. I just kind of remembered that for myself, so don't stress about it. But maybe you know, this little snip is enough. Maybe, you know, a couple notes about it, and then that way if you, and have that on a piece of paper so that if you know, if you have to reference it, you're going to be able to. Okay? That's derivative of the inverse.